Hello and welcome to my presentation. My name is Peter Hammerschmidt. I lead a development organization in the Oracle database team. I want to start this presentation by showing how easy it is to work with JSON and JSON collections in Oracle database. So in our latest release 23 AI, we have the concept of a collection table. It's a special table that stores JSON, similar to MongoDB collections. So it's very easy for Mongo developers to use it. And I can just insert some JSON. And if I select it, you will see not only that the JSON is stored, but also that an ID has been assigned. So this works exactly like MongoDB. It's even better. It's fully MongoDB compatible. So here I use MongoDB Compass and I refresh, look at all the collections that are there, and you see the demo one table is also a MongoDB collection. But let's create another one. Let's create a collection here for movies. I use MongoDB Compass now to create it. I am loading some data and import it using MongoDB Compass. You see I imported a bunch of movies. And I can, for example, look at all the movies here that have a price greater than 5. So this is a filter expression. And if I go back here to Oracle database, you see there is now a collection table called movies. I could just select everything that's inside. That's obviously possible. Then I see the entire JSON documents. Or I could just also extract specific fields. So this is like a big strength of Oracle database, that not only can we store the JSON, index it, etc., but we can also look inside. So here you see I'm extracting some specific fields, and I can make the JSON data look like relational data. This is very easy if you want to do some aggregates, group by, order bys, etc. So this is cool. Oracle database is MongoDB compatible. But we even have more functionality. So JSON has some interesting attributes. And we actually built a new version of JSON that we think is much better to build complex applications or more future-proof applications. And we call that JSON Relational Duality. And what it does, it combines the use case simplicity of JSON really with the power of relational. And for this, I want to do a little bit of a concept introduction. And the example we look at is to build an application to manage a conference. So we're kind of in a conference right now. You're the attendees. There is a session on JSON, and I am the speaker. And if you do data modeling, this is like what's called ER diagrams. You've likely seen that many times before. It's not new at all. Basically list the entities. They have some relationships. And this easily translates into the relational model. So many of you may have done this a lot of times, maybe every day. It's almost mechanically that these entities translate to tables. So we have 3 entities. Why do we have 4 tables? Well, this is because of this end-to-end relationship table. Now, this model, the relational model, has a lot of good things, a lot of good properties. You don't have to duplicate data. And because of that, the consistency is guaranteed. If you only store every value once, it's guaranteed to be consistent. An underappreciated benefit of the relational model is also the use case flexibility. So when we defined this data model, we didn't have to define what the use cases are, whether we have room plans or schedules, etc. All these use cases are possible to work with the same underlying relational tables. But there are also some disadvantages, and they led really to the development of NoSQL databases or JSON document databases. And that is that in addition to the entities, you also need to know all their attributes, right? You need a pretty perfect knowledge about your entities, what are the properties, what are the data types. And this is perceived as kind of static and a lot of upfront work, especially for developers who just want to get started. So what would this mean for an application developer? Let's say we have a use case to show a session schedule. So here on the right, you see a user interface. And in order to populate that, we have to query all the 4 relational tables. So this might look easy if it's just 4 tables, but there are use cases where you have hundreds of tables, so this can get complex pretty easily. And what the application developer would really like is to have like a simpler interface to the database, where you do like a put and a get, and you receive all the information that you need for this use case. And this is where JSON comes into the picture. Like a JSON document can contain all the fields that you need for this specific use case. The values are embedded, and you would just extract them from the JSON, put them on your screen. Maybe you do some updates, you update the JSON document and do a put operation to the database just to write them. And what we did conceptually by using JSON here is we put our entities into a hierarchy. So JSON is a hierarchical data model like XML or YAML. And because we chose the attendee as the top entity, all the other entities are embedded or nested inside of this. So we have this hierarchy: attendee on top, session underneath, and speaker. And if this was the only use case we had to solve for our application, then it would be perfectly fine to just use JSON for this use case. But there are very likely other use cases. So for example, we want to have a session catalog. We want to offer, or we want to show all the sessions that we're offering in our conference. And here the attendee is not the topmost attendee. Instead, it's the session. So here we have a document per session, and the speaker and the attendee information is embedded inside. Or if we want to offer a schedule for a speaker, then now the speaker is the top hierarchy. So what we realize now after just a few minutes is that it's very hard or even impossible to find one JSON document representation, one JSON hierarchy that is suitable for all these use cases. And if we would choose to use JSON for each of these hierarchies, we would duplicate information. So each use case is quite simple, but it's impossible to get one hierarchy that serves like many use cases together. And then we would be ending up with duplicating data. And at the moment you duplicate data, the problem is actually not that you may waste some disk space. Disk space is very, very cheap. But duplicate data means that updates are getting more complex. Now you have to update many more places. And also your data could be inconsistent, leading to application problems, maybe wrong decisions, etc. So the conclusion at this point is that this initial simplicity that JSON offered for the developer causes long-term complexities if you have to bring data into different shapes. And this is where we started a few years ago, where we said, instead of having the application developer to choose whether they use relational or documents, is there a way we can combine the benefits of both, like the ease of use for each use case of JSON, but with the use case flexibility of relational? And this feature is there. It's called JSON Relational Duality, and let's take a look at it. So the main idea here is that you store data independently of each other. So you're not storing your data as JSON documents. You keep your entities separate, very close to what a relational data model would look like. You also get schema flexibility because we allow JSON type columns inside the tables. So you can add new fields as you go. But then we allow arbitrary many views that access this information as JSON. And these access formats or access views are for both reads and writes. So let's look at one. We use the concept of a view, and it's a special view called JSON Duality View. And this one is called attendee schedule because it solves the use case of showing the schedule for an attendee. On the right side, you see the JSON that this view generates. So you see it has all the values for an attendee with the information of the schedule, where the session takes place, who is the speaker, etc. And on the left side, you see how this view is defined using GraphQL syntax. So you could also use a SQL way to define it, but the GraphQL syntax is a bit shorter, and also it reflects the structure of the JSON itself. So we're pulling information from the underlying tables, attendee, session, etc. And we only pick those columns that we need for this use case. So there's also a data privacy aspect. If you don't want certain fields to be accessible in a certain use case, let's say private information, social security, salaries, etc., you just exclude that from that specific view. And then you can also define what parts of this document are allowed to be updated. So for our attendee schedule, so this use case allows attendees to add themselves to a schedule or remove themselves to a schedule. So we would allow updates on this array. Like the application can add or remove objects to this array, but it cannot change an attendee's company, or it cannot change the session's time, for example. So we also allow very fine-grained updates on this document. So as a result, a user can fetch data from the database in JSON format, either using SQL or even document APIs. This is also MongoDB compatible, and work with it. developer can get the document from the database. They don't have to know how the data is really materialized, how the underlying relational schema looks like. They just view it as one document, pull it into the application, make some changes, and place the changes back to the database. We will figure out what changes need to be made to the underlying tables or columns. The other benefit is, and we will see that in a demo in a second, is that you can have many views. And the views can change the same information. So if you make a change through one duality view, all other duality views will immediately see this change. So consistency is absolutely guaranteed. And this approach that I will now show in a demo really combines the simplicity of JSON with the multi-use case power of relational. So I'm going back to my SQL interface here, and I run the statements to create the tables for the attendees and the views. And if I refresh here, you see I create tables, attendee, etc. And you can work with these tables as relational tables as well. You don't only have to work with this as JSON, but we've created views. And let's look at the views in MongoDB Compass again. So if I click here on Refresh Databases, you see that each of these views is also a MongoDB collection. And here I see, for example, that we have some attendees, we have some speakers, and we have the schedule. So if we look at the schedule, for example, for Shashank, we see that he attends 3 different sessions. Now, the interesting thing here is we have 2 attendees with multiple sessions, and there is a typo in our data. Like, this speaker is meant to be me. My name is Beta, not Bodo. So if I were to store this as JSON, for example, in a MongoDB, I would have to go to each of these documents and change Beta or Bodo to Beta. But here, because we use JSON Relational Duality, the data is shared across views. So I could go to another view, the speaker view, and I could make an update here. I could just say, hey, this person is not Beta, it's Bodo. So it's a single update. I only change one record in the database. And if I go to my other collection, which is backed by a duality view, and I refresh this, you will now see that all the data has been changed consistently. So the one change now manifests itself in all other documents. And this is one big benefit of JSON Relational Duality, where data consistency across JSON documents is guaranteed. One last piece of the demo. So you saw that I updated my name here in that speaker view. So let's maybe do another view. Let's maybe update my speaker rating. I think I did a good job. So let's give me a 9 here. So I do document modified and I try to update it. And the interesting thing is that we did not allow in our duality view specification, we marked this field as read-only. And therefore, I get an Oracle error message, which is intended that I'm not allowed to update this field through this view. This is another great capability of Oracle duality views, that I can specify which fields I am allowed to update and which not. And here the rating was not allowed to be updated. So poor me, I have to stick with my speaker rating of 7. This concludes the demo. So now let's do a quick recap about what we've seen. JSON Relational Duality is really the future for data management. It combines the simplicity of JSON with the power of relational. You can have unlimited JSON document shapes with guaranteed consistency among them. You can build document-centric apps over new or existing relational databases. You get efficient CRUD for both relational and JSON data, depending on your use case. You get full parallel SQL for super fast analytics, reporting, or bulk operations. And you can also seamlessly replicate JSON from duality views to other relational systems or even non-relational systems like caches or NoSQL databases. With version duality views, you can decouple your application changes from database changes, which really simplifies upgrading or updating your applications. And what we've seen, you have centralized and field-level JSON security tailored for privacy and critical workloads. There's a lot more in Oracle Database 23 AI regarding JSON capabilities. We, for example, have JSON schema, JSON collection tables, And I encourage you to take a look on our Live Labs platform, livelabsoracle.com, specifically the lab SQL meets JSON in Oracle Database, unify data with duality views, JSON collections, and MongoDB API. Thank you for your attendance.